So if you already sign up for iClicker, you should log in. We have some announcements. One is there is no recitation this week. The LAs and TA and I will meet on Friday, and then we will let you know the office hours. There will be at least 4 office hours per week. And in the past, you can ask for one-on-one tutoring with our LAs. If they have time, they can do that. And physics department will pay for that. I think at least half of the office hours will be on Zoom. Mine will be in person, probably in that space. I think PSF 186. Lecture recording is on Canvas. And also we have few homeworks. Those are just warm up for the whole, for the rest of the semester. The first one is video survey. So it's interesting. It has been fun to watch the videos, I have to admit. Some of you, well, I hope I'm wrong, but some of you may have impression that physics is just information transfer, meaning like physics courses, meaning, you need to memorize and then you recollect the information and then answer the question. So my goal today is to show you that what I'm trying to do is beyond that. I want you to build your critical thinking muscle and also reading muscle in the class. Okay. So I think one of you say that, yeah, it will be good if you can give us study guide before the exams, and the exams will look exactly like the study guide. That thing is not physics class. Right? I will set you for failure if I choose that route. It will be easy for me because I will get good evaluation score from my students, but I care enough about you, so it will not be like that. Many of you send me email about perusal. It is the policy of the class. I want you to read before class, and I want you to continue that in your future classes. And even if you are in the workforce, many of you will be part of a, let's say, company or startups, and people spend, like your colleagues spend a lot of time writing a white paper to be as clear as possible, and your job is to read before the meeting, and during the meeting, you can dominate the meeting and get big bonus at the end of the year. No class on Monday. It's Martin Luther King Day. So that's one. Second, I will be out of town on Wednesday. Phoenix and Arizona apparently is too cold for me. So guess where I'm going? Washington, DC. This is with the intelligence thing. And then my talk will be exactly at the same time as the class. So I cannot even deliver a Zoom class. So it will be recorded. Okay. Any question? Okay. So you guys are really quiet this year. So it is my job to give you excuses to talk. So which we will do today. Right. I may give you money if the department allowed. For anyone who asks questions, I give money. It's a fake money, of course, with my picture on it. All right, so last time, at the end of the class, we talk about what? Thermal expansion. So basically materials, especially hard materials, when you heat it up, because temperature is basically the degree or the frequency and amplitude of how much vibration of a material. Then at high temperature, the vibration is more vigorous. To accommodate more vigorous vibration, then the material has to expand. And this is just a cartoon. In reality, there are millions and billions of atoms. Right? Not just 9, not just 16, 4, 25, but basically Avogadro number. Okay? So the cartoon on the left panel is for a solid in cold temperature. And the panel on the right is for solid in hot temperature. Okay, is that clear? So if it's just purely information transfer, then on the exam I will ask a question along this line. At higher temperature, does the vibration of atoms higher or more vigorous than lower temperature? Higher or lower than in lower temperature? That's just information transfer. But this is physics class. So I want to somehow force you to face possible misconception. Okay, so that's the goal for today and for the rest of the semester. Is that good? So any questions? Clear? Okay, good. Okay, so this is a question. This is an iClicker question. There will be only a few iClicker today because I assume some of you will have technical difficulty. So I'm gonna give you, let's say 90 seconds. I need to set my timer or my stopwatch. And then initially, I want you to commit to think about this question by yourself. So no, okay, so no discussion, okay? So no talking to yourself or to your neighbor. If I see you talking, then I will come with a microphone and ask you to share what you say to the rest of the class, okay? And then after that, I want you to discuss with your peers. Try to find your neighbors with different answers. Okay. So if your neighbor has the same answer, if possible, you just say, thank you. I would rather talk to, I don't know, Jane or John or Muhammad or something like that. Okay. What else? And then if I see you not discussing anything to your neighbors, then I will sit next to you and we can discuss physics. Okay. All right. So this is the question. Okay. So this is the first time. All right. So this is don't worry about the time. It will be roughly 90 minutes. So we have a rectangular piece of a metal with a circular hole in it. And then the question is, you will put the sheet of metal with a hole in it in an oven, basically at higher temperature. The question is, so when the plate is uniformly heated to a hotter temperature, the diameter of the hole will either increase, decrease, or stays the same. All right. So you have 90 minutes to answer. I see. You can even see the dynamics. So remember that at high temperature, the distance between atoms is longer or further apart than at low temperature. Okay, no talking to your neighbor. 60 more seconds. I think almost all of you probably answered. 62%, 29. All right, so maybe 30 more seconds. If you're not sure, just put any answer. So in this class, I think the rule, as far as I remember when I was writing the syllabus, is that if the answer is wrong, you get 3 points. For correct answer, you get 4 points. So 4 more seconds. 3, 2, 1. Okay, good. This is interesting. Okay, so as you can see, the answer, the distribution, what we call it in science bimodal. So there is no easy, meaning like this is not easy questions. If it's easy, then basically typically 90% of you get the right answer. So 40% or like 24% of you says that the diameter increases, and then basically C decreases. Okay. So I'm gonna give you 5 minutes. Find your neighbors and discuss. Try to convince your neighbor that your answer is correct and they're wrong. Okay. Give you 5. Well, let's spend 3 minutes. Okay. It's good to see that you guys discuss with your neighbors. Turns out that I set the timer for 3 hours instead of 3 minutes. So it took too long. So it's good to see that you guys engage. So some of you like physics, some of you don't like physics. Hopefully, at least in those 3 minutes, I managed to engage you. Because if you think about it, it's pretty boring, right? If I just say, meaning like there is nothing more boring than a piece of paper with a circular hole. But somehow, with some social engineering, we do our best to engage you. So it's interesting that only 25% of you answer A and 74% of you answered C. So the answer to this question is, wait, but before before I tell you the answer, you should commit one more time. So I will give you 3 more, like 30 seconds to commit your answer. So it's the same question. So increases is A, stays the same is C, and decreases is C, okay? All right, 5 more seconds. I give you more time. All right, let's say 5 more seconds. 5, 4, 3, 2, 1. All right, so so typically this thing, not how it should go. Typically the correct answer increases by a lot more than this. So let me. So anyone wants to share their answers? You guys are really modest. Pre-meds are really modest. I need to find an excuse to make you talk in the class. All right, so anyone wants to know the answer? Nobody? So I can just go. Okay, you want to know the answer. So, all right, so basically the answer is, but before I continue, all right, sorry. So let's just, because we have been spending too much time on this, typically I have a lot of tricks to just prolong the suspense. The answer is A, okay? So the answer is A. All right, so, and some of you, see, it's good that you guys are engaged. That's the whole point of the class or this activity. But let's think of it in a different context, okay? Because physics is the same whether we are in Mars, the material is aluminum or copper or gold sheet, let's say. So some of you may have done this. I think probably all of you have done this. Let's say you go to Trader Joe's, you buy salsa, and they have the habit of tightening the cover or the lid too much, right? So what would you do? Typically what you do is you put it under a stream of hot water. And in that case, the lid will expand, right? And then you can open it more easily. So some of you may say, but it's not fair, it's not the same. This is a lid. Your question is a sheet of a metal with a hole in it. So you may argue that it's different. So imagine that you have a piece of metal. I know this is not a piece of metal. And then you increase the temperature, the area of the sheet will increase. And what you can do is you can draw lines or circular lines. And then what happens when the area increases, the circular lines also grows bigger. And some of you may raise your hand, since no one raised his or her hand. It's not fair. There is no hole in it, right? So basically, imagine that there is a hole. If there is a hole, then the small and if the hole is small or bigger, both of them will expand. Hot, cold, hot, cold, hot. So why do they expand? Remember, the most important, or the only information that I gave you is the distance between the atoms. At higher temperature, the distance between atoms is further apart, is longer. So imagine like all of us go to, I don't know, Sun Devil stadiums and make a circle. In order to make the distance between all of us in that human circle larger, we have to increase the diameter of the circle. Is that clear? Clear? Good. I hope you will not forget about this. And at least, you will remember this longer than compared to if I just tell you the answer right away. All right, so in terms of the reason why we do this, I don't know, theatrics or gimmick. Some of you say that my wife is a gimmick for this class. This is a study from a not ASU, different university. Basically what they do is they engineer a bracelet. So this is not about physics class. This is just study for technology development. And what they measured is, I think, epidermal voltage. Epidermal something. So this is not like EKG, but it's similar to that. And what they found is that the signal that they measure correlates with brain activity, which is not surprisingly because our nervous system is connected throughout our body. Right? Okay, so what you see here is, okay, so this student, also, so many graduate students wear this bracelet and do what they do in a few days, and they can download the data or the trace of the voltage. So the student go to the lab, watch TV, study, sleep, and class, okay? So what you see is that in class, so you can compare the brain activity during sleep and during class. Okay? Sleep, class. So basically this data shows that, so first, these experiments involve electromagnetism that you will study. Second, many students actually far more asleep in classroom than on their beds. So this is why we will have a lot of iClicker questions. And what is a more interesting thing? It's also interesting that when students watch, so this is an old study, right now probably TV is TikTok or YouTube, K-pop maybe. What you see is that the same thing happened when you watch YouTube, because it's, you get a lot of information and you don't have time to process the information. So by discussing physics with your neighbors, I want you to confront your misconception and try to convince others that your understanding is correct, okay? And don't worry about iClicker, don't worry about perusal. Most of your grades will be based on your exams. Even if your iClicker is all wrong, you still get 75% and then divided by 0.9, because 90% of iClicker is 100%, which is still pretty good. Any questions before we do the real physics 112, which is electromagnetism? No questions? All right. So in the first semester, you study basically mostly F equal to MA. Is that right? Mechanics. Do you remember? Oh, sorry. So and that includes gravitational force. You guys still remember that? Okay, good. But the big picture, maybe this could be your last physics class, but there are 4 fundamental interactions in physics or in nature. One is the one that you already studied. The second one is the one that we will study, which is electromagnetic interaction. We will spend basically 60% of the semester on that, or 50% of the semester, exam 1 and exam 2. The other 2 are more advanced. One is weak interaction. This is the interaction that responsible for radioactive. So if you are pre-meds, this is the underlying interactions that lead to, let's say, radiation therapy or all those imaging like X-ray. The other one is strong interaction. This is the interaction between quarks and gluons that hold nuclei together. So our department has one Nobel Prize laureate, Frank Wilczek. He contributed substantially to, the name is quantum chromodynamics that relates to strong interaction. So that's the closest thing that, that I could be to a Nobel Prize, meaning in the same department as a Nobel Prize laureate. The other two laureate, I think in 2004 are one David Politzer. He was actually taking my class when I was at Caltech. And he did his homework. True story, I'm not joking. So a Nobel Prize laureate still go to classes and do his homework. So if you think homework is not important, then even a Nobel Prize laureate did that in my class. He did change the questions. So so it was interesting experience for me to grade his answer because he didn't answer the question. The other one is David Gross. He's at UCSB. He and I gave invited talks in Bali when I was a graduate student. So that was a lot of fun. One thing that I also want you to do in this class is if you are exposed to, let's say, a new force, you should think in the context of how to measure it, and don't just think about how to get the answer or how to manipulate the symbols. This is probably like 30-minute lecture on this, so I will just talk about it briefly. One thing that I like to do when I think about physics is try to figure out how I can measure it, how I can see it. For example, this question, how do you know that there is force? Right? How do you know, let's say, well, this is kind of difficult, but how do you know that there is gravity? So one thing that you can, from your first semester of physics, F is a vector and then M, A. Right? So if there is anything that accelerates, that means there is force. There is like Hookean force, like spring, for example. You have a mass, and if you pull the mass will accelerate and decelerate and accelerate and decelerate. That means the spring applies force. That's what many of us physicists approach a physics problem, like how can we measure it? And typically that leads to deeper understanding. All right, so you still remember about gravitational force, right? What do you remember about it? Yeah, oh, actually your seat has number? I see. I'll use the seat number in next lecture. Yeah. Yeah. No, okay. Thank you for your answer. Anybody wants to share? Yeah, go ahead. Oh, the camera. Ooh. Thank you. What's going on here? Maybe because of me. Good. Somehow the autofocus didn't work. Okay. So gravity is basically if you have two masses. This could be Earth and Moon, or Earth and you're sitting in my class. Then there is a attractive interaction. So F gravity is equal to what? There is a universal constant, G, gravitational constant, times M1, M2, divided by the separation between M1 and 2. This is R. And there is a directional vector, which is the direction between they connect the center of masses, centers of mass of the two objects. Okay? And if you just care about the magnitude, then we can do this. You remember that? Yes, okay. But now I'm going to do a demo. This is my God. Sorry. Okay. So unfortunately, you pay a lot of money for your tuition to see me doing this. So I'm gonna, I have this comb that drives my wife crazy because it looks weird. And then I have this paper. So it's just paper, nothing, nothing spectacular really. And then let's see, I haven't practiced this and hopefully it works. So first I'm gonna comb my hair. Okay, and then see if this paper is, okay. Oh, it doesn't work. Maybe it's too big. But you guys have done this, right? These experiments. This is something that you can do in your dorm rooms. You comb your hair, and then you can see that it can leave paper, right? So what is this force? Now the question is, what is this force? You may say that it's gravitational force. Who thinks that the force is gravitational force? Right. The answer, it shouldn't be the case, right? Because gravitational doesn't care whether I comb my hair or I don't comb my hair. You want me to do it again? So you guys are really quiet this year. Okay, so yeah, because it doesn't care about, like, gravitational force doesn't care about, there is no, given that mass 1 comb its hair, right? There is no conditional term there. So it should be different force. So we need to come up with a different force, and you don't need to know this formula today, but you will learn about it next time. So electrostatic force, which is K Q1 Q2 divided by R squared. Oh, this one is R squared. Sorry. Okay. Did you pay attention that after I pull the paper fall, right? So you may think that the magnitude of gravitational force is bigger than the magnitude of the electrostatic force. Because the paper, let's say the electrostatic force pull this thing up, gravitational will put it down, right? But one thing that you need to remember is that gravitational force, what pull this paper is, what pull this paper? What apply gravitational force to this paper? This table, the floor, the earth. If you follow K-pop, I don't know, Jungkook maybe, I don't know. I mean, Jungkook means squat in my language. I don't know, like kangaroo in Australia. Everybody pull that piece of paper. So at the end of the class, we will calculate that the magnitude of electromagnetic force is far larger than gravitational force. It may appear that gravitational force is larger, but it's actually far smaller. The reason why it appears larger because m here is the mass of the Earth. Okay. So based on that, you may ask question: if electrostatic force is so dominant, why we don't see electrostatic force all the time? I need to give you guys excuse. Anyone with ASU gear? You. What is the answer? You. Yeah, because most things are neutral. So let's talk about charges or the subatomic particles. And you guys have seen this, right? There are a few subatomic particles. Okay. One thing in okay. One thing in science or in physics, we like to use the word ons. So I will like the subunit of negative charge, we call it what? Electron. Right? Electron is basically subatomic particle that carries a negative charge. How about positive charge? Proton, right? And there is another fundamental subatomic particle, which is neutron. And I was told this morning that this class also, every student, the subunit of the class, which is you, also ends with on. Anyone knows? It's like person. Anyway. Will not be mixed up. Sorry. So neutron. So electron, the charge is negative. I see. In chemistry, probably you call it -1, but the unit in physics is coulomb. And we put E, which, yeah, let's just leave it at E. Proton is plus E, and neutron is 0. And in terms of masses, electron is far lighter than proton and neutron. Do you guys remember that from your chemistry class? Okay. So when I first learned about this, I find it remarkable because there are many electrons in the world, right? And one thing that is amazing, at least to me, or maybe hopefully to all of you, is that all of them are equal. So some of you hate Elon Musk, like my wife. Some of you love Elon Musk. Elon Musk, his company builds Tesla, but every Tesla is actually different, slightly different. And a few of them probably don't work, right? But electron, all of them, Avogadro number times, I don't know what, billions, millions, they all have the same mass and the same charge. Okay. And neutron and proton is in nucleus, and electron orbits around it, at least as of now. At the end of the semester, we will learn about quantum mechanics, and I have to change the wording a little bit. Any questions so far? So this is basically what I just said, that all electron and protons, all electrons are equal, all protons are equal, and somehow the charge, their charges are exactly the opposite, which is remarkable. And this summarize the table. This E is what, 1.9? No, 1.6 times 10 to the minus 19 coulomb. So some of you may not happy with this 10 to the minus 19. This is because coulomb is derived based on a different experiment that involve current or ampere. Another thing is that charges, they are conserved. You cannot create, you cannot destroy. They move. For example, electron move from my hair to this comb and polarize this neutral paper. So charges move within the material and can transfer from one object to another object. Okay. Any question? This is actually not somewhat subtle after you learn about quantum mechanics and Heisenberg uncertainty. All right, so I have this iClicker question. it's what number, I think, sorry. It's actually multiple choice. Okay, are you guys ready? So the question is, this is basically math question. How many electrons in a piece of iron that has -1 Coulomb charge on it? So again, E is 1.6 times 10 to the minus 19 Coulomb. Okay? And I give you 2 minutes. Seconds. Thirty more seconds. All right, 10 more seconds. Almost all of you already log in your answer. All right. Good. So the correct answer is B. So basically, the material has 1 Coulomb, and each electron has 1.6 times 10 to the minus 19. So what you need, the calculation that you need to do is 1 Coulomb divided by 1.6 times 10 to the minus 19. Coulomb, the unit cancel. So you get 1 over 1.6 times 10 to the minus 19, right? Got it? And this is basically roughly 0.5, but it's bigger than 0.5. It's 0.62 times 10 to the minus 19. 6.2 times, I move the digit to the right, should subtract the exponent by 1. Easy? Good. All right, so yeah, maybe we can do the comparison. Well, we can just do it right now. So when I say that gravity is, or electricity is gravity, it's actually far, far stronger. So you can come up with any toy model, but physicist's best friend is a hydrogen atom. Hydrogen atom is basically just positive charge and one positive charge and one negative charge, or one proton and one electron. We know the masses of electron and proton, so we know M1 and M2. Okay. The distance is Bohr radius, which is given here, right? So the R square is known, which we will learn next lecture. So for electricity, the charges are Q1 and Q2. Q1 could be electrons, so minus E. Q2 could be the proton. What I mean by Q could be, because you have the choice of which one is 1, which one is 2. There is no correct answer. It's up to you. One could be electron, two could be proton. So we know the charges, we know the distance, we know the universal constant. If you put the number, which you can do yourself at home, one of them is on the order of, so this funny O means on the order of 10 to the minus 46. The other one is 10 to the minus 7th. And, I see. And if you do the math, 10 to the minus 7th, 10 to the minus 46, is that right? Yeah, so this one is basically equal to basically 10 to the 40th. I mean, this is back of the envelope. If you want to be very accurate, but basically 10 to the 40th. So 10, so something with 40 zeros. So it's a much, much bigger, much, much stronger. Next, in your reading, you study about electrical conductors and insulators. Basically, conductors are materials that allows electricity or electrons to move. So electrons are the active ones. All of you perhaps still remember from your chemistry classes. And we always say that the reason why it should have positive charge instead of negative charge, we are stuck with that convention because of, I think Benjamin Franklin is the one that gets credited by the sign or by the negative sign of the electron. So the reason why conductors, so most metals or all metals are conductors because in metals, the electrons are shared by all atoms. On the other hand, for insulators, insulator does not allow electricity to flow. The charges are localized. They are not shared by the whole atoms, like unlike in metal. One example is probably sodium chloride. Sodium chloride, each atom is bonded by ionic interactions, and it doesn't conduct electricity well. And most materials are insulators. There is another material that is not listed here that you read in your perusal. Do you guys remember? Semiconductors. Yeah, semiconductors is in between. It's actually very important. If you are interested, you can take solid state. Basically, the conductivity can be tuned by voltage. And that's the basic of transistors in our cell phone. So basically, you can allow electricity to flow through by applying voltage. And because electrostatic is strong and you can do it really fast, your iPhone or your cell phone can work really fast. Compared to, let's say, many pre-meds in the room, DNA replication, let's say. DNA replication is typically what? Like 100 hertz, meaning like one nucleotide every second or 1,000 nucleotide every second. This one can go up to a lot more. Is that clear? Or you guys have questions about semiconductor? All right, so next, before I let you go, there could be more than one answer to this question, okay? And let's just spend 30 seconds. The question is, which material are electrical conductor? Plastic, milli-Q or pure water, tap water or unpurified water, copper and wood. Five more seconds. All right, good. So the answer, many of you are correct. One of them is more than the other. Like more students vote the other option than C. But unpurified water is also a conductor, but weak. We call it weak conductor. So what's going on here? I still have a precious 1 minute. So next meeting, we will finish the perusal one. So we are a little bit behind. So that last question is a practice. So we will do perusal fast next lecture, okay? Because we are already behind and this is lecture number 2. All right, have a nice day. I'll see you on Friday.
Like this is a little confusing. Give me wrong, even though I selected the 2 correct answers.
Don't worry about it. It's only, you only